Hello guys, this is Electrobot and today I will show you the simulation of the speed control of DC motor using potentiometer. So for this we have to open the simulation software Proteus 8. So then we have to go to the file, then new project, initializing the project wizard. Then we have to uh, name it as the DC motor, sorry, speed control. So then we have to click next. So since we then we have to create a schematic is landscape for it. This will be always the default. So then we have to click next. Since we do not create a PCB layout, so we have to select this option. Then click next. Then next. Then finish. So this type of background you will see in this simulation software. So my file name is DC motor speed control, and the date we I made this, I make the simulation. Then first of all we have to select the components. To select the components we have to open this uh, component mode, or you can this component mode. From there you can uh, type any component you want, and this is the component bar from where you can select the components. And then you can also select from this is also component mode, select it. Oh, it is already open, sorry. So now we require component which is DC motor. We took this simple DC motor as not very, not this one, simple DC motor. Then click OK. Then we need a 9-volt source, so a battery. Sorry. This is multi-cell. In this project multi-cell is not required, so we can only use a DC voltage source. uh, we only need this cell device. Then click OK. Then we need a potentiometer, which is POTG, pot, sorry, PO. So we can use this is variable resistor. So click OK. Then we place this component one by one. Click on the cell and place it. To maximize so we can better visualize it. Yes. So Then we have to place this this register. Since so we can rotate this register by uh, right click on it and edit proper not edit properties, rotate clockwise, this one, in this way. This is okay. Now we need motor, so click on it and place on it. Just simple, this way. Yes. Now wiring it. So now we have to change the value of battery. It is ready to 1.5 volt, but we need 9 volt voltage source. So here click on it and edit properties, and you can edit this value as 9 volt. Click OK. Yes. Then 1K register we needed. So for every circuit design we need one grounding, because grounding is very essential. Without grounding you cannot simulate a single circuit. So for grounding we need to go to the terminal mode. Click on it. There you will find the grounding. So click on it and place it. Then wiring it. So in this way. So let's run it. Okay or not. So okay. Actually we stop it. Actually we need another register. So then go to component mode. It is not this one. Component mode and search for POT. So let's remove it. To then we have, if we want to delete any component from the simulation, then we have to go to selection mode. This is selection mode. And click it. Click object. Place it up. Place it. Yes. Now rotate it clockwise. Yes, this is perfect. Oh shift. Now wearing it. So this is our simulation circuit. So so here it is written that it is 50% resistor placed in there. So now we can simulate it. As we decrease resistance, speed is increasing. As we increase resistance, the speed is almost decrease. So let's change this motor because I can't find it suitable for rotating. Stop it. Then device DC motor. Yes, this is perfect. Yes, in selection mode and delete this part. Delete this object. Place this object. Now rotate it clockwise. Sorry, anti-clockwise. Then wiring. Oh, my circuit is absolutely perfect. Now I can simulate it. So as you see, my motor is rotating. 11.2 RPM. As I decrease the resistance, my speed is increasing. See? As I increase the resistance, my speed is decreasing and motor sometimes will stop rotating. 66, 64, 61, 57, 56. So let us change this motor. Put another motor. How this work? So let us stop the simulation here. fan load. So click the object, put the DC motor here, is fan load, it anti-clockwise, yes, no, wiring, this is K RPM, means kilo RPM. So if you want to RPM, so you have to convert it by multiplying it 1000. See, 2.14 KRPM means 0.21 RPM means 210 RPM, 240 RPM, 22 RPM. Speed decreasing actually, speed vary. So I want to increase the speed of motor, so let's decrease the resistance. See, 0.67, 0.678. So there is also a back EMF generated in the motor, and if you want to measure this back EMF, then you have to connect a voltmeter across this motor, and if you want to measure the current in the circuit, then you have to connect an ammeter in this wire. So let to the 50%, stop the simulation. Now we can go to this instrument section. Here you can find DC ammeter, DC voltmeter. Click it. So I have to cut this portion of wire, so I have to go to selection mode and select this wire and cut. We have to cut it, delete the wiring. So DC, we need DC ammeter, so place it over, and first of all we place the DC voltmeter here, then we place DC ammeter here. Perfect. Now then we have to join the wire. Now our circuit is finished, then we can simulate it. So here we can see the back EMF of the motor is 9 volt, 1.43 volt, and it is vary because this is a 9 volt source, no, and it will vary. So current here is a 0.01 ampere something, 1.54 volt, 1.78. So current is also varying. So let us um, increase the decrease the resistance, then see what happens. Speed of motor is increasing. See, 0.03 ampere current. So if you want, suppose in your college project or school project, you want you want the PDF of the schematic diagram. So what will you do? Then you have to stop the simulation, then go to File, Export Graphics, Export Adobe PDF file. Okay, now you will get this PDF like this. So if possible, I will try to share this PDF in the description. You can download it from there. So if you like this video, don't forget to like, share and subscribe.